BKL Knowledge Lab, we conduct research into how computational techniques can be used to enhance users' engagement with learning and knowledge creation processes.
We do interdisciplinary research which essentially looks at both social science, computer science and other disciplines and sees how we can work together.
We work with educationalists and psychologists to understand how people learn and how we can design software to enhance students' learning, and also tools for teachers to support them in their multiple roles.
Fractions Lab is an exploratory learning environment for children between 8 and 10 years, and it includes intelligent feedback and support that is able to be adaptive based on the students' affective states.
Please explain what you are going to do next. You might find it helpful to rate the task again.
The system I'm working with is called the Fractions Lab, and my part of the research project was to provide a visualization layer that would help people understand the data at a more holistic level.
I'm trying to shift teaching of computer programming from human tutors to intelligent agents.
Our research on a recommender system for the learning designer aims to design an intelligent system that will help teachers rebuild, test and improve their learning designs in order to help their students improve their learning to reach their maximum potential.
We have developed a virtual learning environment based on Moodle. The LibVLE extends Moodle with a new personalization plugin that aims to personalize learners' experience in numeracy, literacy, problem solving and IT literacy.
One example of tools that we have designed for teachers are awareness tools that help maths teachers to monitor their students' progress through learning tasks that target algebra. The tools help the teacher see who is making good progress with the task goals and who is in need of the teacher's help.
At the BKL Knowledge Lab, we get inspiration from recent breakthroughs in genetics, psychological sciences and neuroscience to create new models, computational models and systems that possess human-like characteristics and are able to operate in changing environments. For example, recently we have a collaboration with neuroscientists and developmental psychologists researching the ways children learn new things and develop their cognitive abilities early in life. And from this research we designed a new generation of machine learning algorithms that would be able to operate in changing contexts, able to transfer knowledge from one context to the other. These methods would be able to make systems more intelligent and adapt to changing environments.
One of the drawbacks of most machine learning methods is that every time the neural networks they encounter a new problem, you have to train them, and the entire cycle has to be repeated from scratch. And what it often leads to is that when they learn a new task, they forget, it overrides the previous knowledge. So they forget or their performance declines on the previous task. So I devised a method which kind of enables them to acquire multiple tasks without catastrophically interfering with previously held knowledge.
We are trying to automate the process of detection of autism spectrum disorders based on EEG signals. The aim is to detect ASD at a very early stage in life, around 12 months old infants. And we are trying, by developing these new methods, to be able to direct interventions to groups of children that most in need, and make an early prognosis of the development of ASD.
We are the BKL Knowledge Lab.